All right, we're back recording. We've got a few minutes left. All right, let's do some review. All right, so I'm going back to kinematic days. That's this red banner. All right, guys, calculate from scratch or on your paper in your notes. Figure out what's the reaction time based on how far the ruler's fallen. I've got covered up pretty much what I want you guys to be writing in your notes. See if you can figure that out from scratch. Figure it out from scratch. I'm just gonna flip through the roller coaster if I see anything interesting here.
Yeah.
See this one.
I got it.
Going back to kinematic days here.
That's I don't remember.
Huh. Okay, so if you want to figure out reaction time based on how far it's fallen, something to do with distance, something to do with time. That sounds like a job for which one of these kinematic expressions? Yeah, the first one's the only one that has both the distance and the time in it. The second one doesn't say anything about distance, third one doesn't say anything about time. Something to do with the first one. If you drop the ruler, you can simplify this first expression by doing what?
Removing the initial stuff.
Yeah, initial velocity would be 0. So this term just goes away. Isn't that it? Hey, is that the college equation right there? Is that college? It's a college equation. Can you solve for that time? Right, so there's first step. The height change is 1/2 gt squared because gravity still could be an acceleration. I bet you guys can do the algebra and solve the rest of that, right? Just make sure you can in your notes. Stay a step ahead of me. Okay, so times 2 over g looks like that. And what's the last algebra step? Yeah, square root. So you guys can do that, right? You see that? Okay. I hope you understand that. If for no other reason, guess what your next question is? But it's going to involve that. Does everybody have that in their notes? Have that in your notes? All right, next thing. This was a lab you guys did a long time back, and it also involves what you guys just did in the last minute or so. Okay. You guys remember going out to the balcony, and you guys were blasting balls horizontally, and you're spotting exactly where they land. Yeah. And you took either a meter stick or a trundle, and you measured how far did the ball land out. You measured that. You also measured the height of this balcony. You're also allowed to know Earth gravity. Okay? So you're allowed to know Earth gravity. And I want you guys to calculate what was the blast speed. Now over here, underneath this paper, I got covered up the answer. Guys, what is the blast speed in terms of this horizontal distance, d, this height, h, and Earth gravity? Okay, go ahead. It's a good challenge question here. Okay. So there's going to be a series of steps. And the very last step to get the answer, trying to help you guys out, I want you guys to say V blast equals, and it's some expression. Some expression. It might have a square root in it. It might have a fraction in it. It's going to take a few steps to get to that point. But I give you guys a few minutes to solve that. Yeah, everybody has paper nearby. Initial here, notebook. Look at the blast speed. Look at the blast speed. Okay. How fast is that launcher blasting that ball? Okay. I want it in terms of H, D, and G. The time's going to cancel out. Okay. So maybe that's a hint too. Okay. So the final answer, final expression, is in terms of D, where did the ball land horizontally? H, the height of the balcony, and also Earth gravity. And the time ends up canceling out.
I don't think I did. Oh, I derived the reaction stuff. Okay, I got reaction time. Yeah, that's part of it.
Guys, if you were taking notes a couple of minutes ago on the drop the ruler and reaction time, that's actually part of it. Right, so you're actually halfway there if you were taking notes a few minutes ago. Remember, stop projectile where.
That's good. This is funny. Right. So is this not
No, no, this one's crafted. Oh, yeah, there was no. Where do you know? That's not your house. So, I would, no, like, not from you, but.
It's the same time it would take to just.
Oh, it's just, okay,
Does anybody think they have it yet?
Why?
Yeah. All right. Brian got it. All right, let's get this.
I don't even know what it was. What was the midterm in this?
I'm not even halfway done.
Figure out how much time it takes to fall down.
Oh shit, everything is bigger though.
Then after that.
You brought that or something. Yeah, dude, sleeping. Wait, so it's a D?
All right, one more minute. One more minute.
One.
You smart.
Logan got it. Got two winners.
E over. This has. Is that one? Times. The two things.
And it's kind of it.
Yeah, but I would think that people are now.
How does it? That's a lot.
Open your numbers.
I'm gonna have to.
Open your numbers.
I don't think they will.
It's ideal.
They're like all state level people.
Okay,
They're
but
like all state level.
Yeah, but that's not
like,
what
like,
you
orange ones.
It is.
it's D over so.
Two H over G.
Lauren got it.
That's. Not putting anything else.
Yeah, Richard got it. Got it. All right, get some winners now. Yeah. You got it. All right. Nice job. Nice job, guys. Okay, so here we go. Let's go step by step. Step by step here. Right, so there's a vertical part that I wrote in red. There's a horizontal part put in green. And there's substitution put all together. The answer is here in black. And so the red part is the same as the roller drop. H is 1 half gt squared. You rearrange that and solve for t. Now, this is the time it takes to get from the beginning to the end. Okay, so wouldn't it be the same time whether or not you drop the ball straight down or if you throw it horizontally? Does it take the same time regardless? Yeah, they all have the same vertical motion, which is all in red right here. Same as the ruler drop. Square change of g. Okay, so you hold on to that. You say, okay, well, what's going on horizontally? That's over here in green. So, isn't it distance equals speed times time? And oh, guys, whatever the blast speed is, does that horizontal component stay the same all the way across? Right? Like if you take a picture every equal interval, notice how the spacing is the same all the way across. Right, so it's, blast speed would just be how far did it go divided by how much time it takes to get there. Isn't that true? That's every time. Last step is take this time expression, sub it right here, okay? And it's this d divided by root 2h on g. Okay. Now you could also rearrange it this way. Because if you have a fraction with in the denominator of another fraction, can you take the bottom fraction and flip and multiply it? Okay. That's why this and this flipped upside down. Right? So you can multiply by the reciprocal. Take that. Okay, you guys good there? Alright, I think I got time for one more with you guys. One more. And oh, where did it? Oh, here it is.
Still done.
Okay, the car breaks to a stop. If you remember, it's how to draw these three graphs: distance versus time, velocity versus time, acceleration versus time. All right, last question. You can draw those three graphs.
Well, I know this.
Three graphs: distance versus time, velocity versus time, acceleration versus time. Car breaks to a stop.
Lost them.
Breaking to a stop.
It starts at a certain speed, it's not solid. Yeah. Bottom load, you just start below, or it starts on zero acceleration, then it goes zero.
Hey, Chris almost got it. Chris got it. All right.
So let's just.
Yeah, he did.
Diagonally.
Brian got it.
Oh, you're from him, is that what you're calling?
Yeah. All right. Table one back here. Yeah. Yeah.
Exactly.
Remember, and Jonah, Logan, got it. Right, so here's what you guys should come up with. The car breaks to a stop, velocity corrects some value, goes to zero. And if it breaks uniformly, this should be a straight line. The acceleration is a constant negative value, that goes hand in hand. Okay. And the car, guys, is the car still moving forward while it's breaking to a stop? Yeah, still moving forward. That's why it's accumulating positive displacement as time goes on. But guys, what shape is this right here? Parabola. And what point on the parabola is this right here?
Vertex.
Vertex. There you go. Yeah.